So today we're going to cover section C, or the day 3 of section P5. And today we're going to learn how to add and subtract rational expressions. So remember back when you were adding simple fractions, you always had to find the same denominator, or the LCD, the common denominator. However, you must always factor that denominator first. Then you're going to find the LCD of each term, and you're going to raise it to the highest degree. Then what we're going to be doing is multiplying each term by what's missing from the denominator. Then we'll add and subtract the numerators, and then we'll use the LCD as the denominator. And you're going to see what all these steps mean on the next slide. So let's just do examples now. Now, here is a nice, easy, simple adding and subtracting fractions like you did in 4th grade. Okay, now, when you add and subtract fractions, the denominators must be the same. So we have to look for the least common multiple between 2 and 3, and that common denominator or least common multiple will be 6. Now, remember, once we change the numerator, we're not adding to get to it. So I'm not saying, oh, I got to add 3 here, so I add 3. I'm multiplying by 3 to both the numerator and the denominator. So then this new numerator would become a 3. Over here, to change the 3 to a 6, I times it by 2. And then now that you have the common denominator, you just go back and add the numerators. So it'd be 3 plus 2 over 6, which the final answer would be 5 over 6. So remember, when you're finding a common denominator, you're not adding to make the denominator get higher. It's always multiplying. And whatever you do the bottom, you do the top. Let's try number 2 below. Again, nice and easy. My common denominator here would be a 12. Now, the second fraction is good. It already has the common denominator, so I don't need to do anything to the second fraction. However, my first fraction, in order to make the 6 a 12, I'm timesing it by 2. Whatever you do to the denominator, do to the numerator. And then now you just add the numerators. You keep the common denominator the same, and then reduce the fraction. And we're done. Now, the fun begins with the binomials and the trinomials and just the general polynomials, which we may have to factor by grouping. So for this one's already, oops, I need to go up here. This one's already got the common denominator. My common denominator is x plus 1. So since I already have a common denominator, I'm just going to add my numerators. 1 plus 2 is 3 over x plus 1. Remember, you do not add denominators. Once you have the common denominator, it just stays that LCD. Nothing here simplifies, so I'm finished. For subtraction, you need to be very careful. Think of this as like a keep, change, flip, or a stay, change, change. This has a common denominator, so this part's good. However, you need to remember that you're subtracting this entire numerator. So really what we're doing is you keep x plus 1 the same. So it's really x plus 1 minus 2x minus 3. And then I need to distribute the subtraction sign to both of the terms that I'm subtracting. And now this is what it becomes. I'm going to add my like terms. So now I have this over that common denominator. I'm going to add my like terms. I have an x, a 1x, minus 2x, and that gives me negative x. Then I'm going to go back and add my constants, and I have 1 plus 3, and that gives me 4. And it's over the denominator. Remember, these are attached together. Do not try to simplify the 4 and the 2 or the x's. That is already in simplest form. So again, remember, we are multiplying to find the LCD. So let's try number 5. All right, number 5. Again, we need to find a common denominator. So notice the common denominator here is going to be the 6x. So what the first fraction is lacking is the 6. So what I'm going to do, and let me just go ahead and rewrite this, the original problem. So my LCD is going to be the 6x. But what I need to do here is multiply this one by a 6. Whatever you do to the bottom, you do to the top. So my new fraction for the first one is going to be 6x with 6 on top. And then over here, this fraction stayed the same. Now that I have the common denominator, I'm going to add my numerators. 6 plus 5 is 11 over 6x. For number 6. Now remember, back to this one where it was 1/2 plus 1/3. I can't say that my common denominator is 3 and then just add 1 to make it a 3. This is the same idea here. I can't just say I'm going to add plus 1 and then plus 1. If you do that, you get it wrong. Remember, we're multiplying to get the LCD. So what I'm going to do is my common denominator is going to be both of these. It's going to be x times x plus 1. So let me set it up for both. And now we need to figure out what each one was missing. So the first one was missing the x plus 1. So you're going to multiply that to the top and the bottom. So then that's what went in here. And then the new numerator, 1 times x plus 1, is just x plus 1. Then over here, this one is missing the x. So we're going to times this by an x and this by an x. Now that I found the common denominator, now I need to add my numerator. So now it becomes x plus 1 plus x, and then it's over the common denominator. So again, I'm going to add my like terms. I can add 1x plus 1x, and I get 2x plus 1, and then I have x times x plus 1. Nothing simplifies here, so I'm finished. So for number 7, same thing, but now it's subtraction. So my common denominator here is both of these. I can't just subtract or add 2 to the second one to make it look the same, or add 6. I need to multiply. So my common denominator is going to be x plus 2 and x minus 4. So this one is missing the x minus 4. So whatever you're going to multiply to get to the bottom, do to this top as well. Then the second one is missing the x plus 2. So again, let me set up. So this already had this one, and now I'm multiplying it with the x plus 2. And then I need to do the same thing to my numerator. So the 3 was already there, and then I have the x plus 2. Now that I have the common denominator, I need to distribute the numerator and then combine like terms after I subtract. So the first fraction, I have x minus 4. Now what I can do here is like a key flip change this and make this a negative 3 that I distribute. So then I'm left with negative 3x minus 6, and it's on top of the x plus 2 and the x minus 4. Now I'm going to add my like terms. So I have an x, a 1x, minus 3x, and I get negative 2x. And then I can add my constants. Negative 4 minus 6, and that gives me negative 10. And it's over x plus 2 times x minus 4. Now, what you should do is just make sure that if you were to factor this, I can factor out a -2, and I'm left with x plus 5. I need to check it to see if anything would cancel. Nothing simplifies, so in this case, I would accept either this answer or this answer. Yes? Common denominator is both again. So it's going to be this and this. So the first fraction is missing the 3x plus 4. So again, I'm multiplying to get that in the denominator. So my common denominator is 3x plus 4 and x minus 3. And let me set this one up as well. And what this fraction is missing is the x minus 3. All right, so now for the numerator, I could just go ahead and set this up like this for now. So what I need to do is distribute this before I combine like terms. And then the same thing over here with the blue, I'm going to need to distribute the 2 into that x minus 3. So now let me go ahead and multiply and distribute here. So for this numerator here, I'm going to distribute the x to the 3x and the x to the 4. And then over here, same thing. Now, this subtraction, if it's easier for you to think of this, keep flip change and make that a -2 to distribute. -2 times x is -2x, and -2 times -3 is +6. Now it has the denominator, it's already factored. I'm leaving it alone. Do not FOIL it. And now I need to go back and look for like terms in my numerator. So nothing to add to the 3x squared. However, I've got like terms right here with my 2 x's. So 4x minus 2x is just 2x. And then the plus 6. And then it's over this. Now, you should try to factor.
Is it prime in this case?
Yeah, you can't factor that numerator because once you try to do grouping, 3 times 6 is 18. And the factors of 18 would be 1 and 18, 2 and 9, and 3 and 6. So none of those would give me a 2. So this is your simplified answer. Okay, so here we need to find a common denominator. And on number 9, it's going to be both of them again. So I'm going to go ahead and put 2x minus 1. And then x plus 2 over here. Now the first fraction is missing the x plus 2. So x plus 2, and then you have to distribute the x. And then over here is a 1. And then this one is missing the 2x minus 1. And now I need to distribute x to the x and x to the 2x. And then over here, I could treat this as a -1 that I'm going to distribute. So -1 times 2x and -1 times -1. And then it's got the common denominator. So x plus 2 over 2x minus 1. So now I need to combine my like terms. So for here, I can combine, nothing to combine with the x squared. Notice my 2x and my minus 2x is 0. So then I just have plus 1. And then it's over the common denominator. The numerator cannot be factored I cannot factor the sum of two squares, so this is my simplified answer. Now, you always need to factor the denominator before you look for a common denominator. If you don't factor it, then your problem's going to get really ugly, okay? Because if you think your common denominator is x squared minus 9 and x squared plus 3, you're going to get a monster that you're going to have to simplify in the end, and it gets really bad. So always, always, always look to see, can I factor my denominators? And the denominator of the first one factors into x plus 3 and x minus 3. So now that is changed, and now we won't use this because this is what we're using now. Notice my common denominator is going to be x plus 3, x minus 3. This second fraction already has part of it. So the only thing it needs now to multiply is x minus 3. So the first fraction is done. It's 2 over x plus 3, x minus 3. The second fraction, you need to distribute the 4 to the x minus 3, but now the denominator is the same. So I'm going to distribute. So the first fraction is just the 2. I need to distribute the 4 to the x and 4 to the negative 3. Then it still has the x plus 3, x minus 3. I now need to combine like terms in that numerator. Only thing I can combine are the constants. So I'm going to be left with 4x minus 10. And then that's over the x plus 3, x minus 3. Now, if I factor out a GCF here in my numerator, it doesn't help me to factor anything. So on the test, I would accept either answer. However, if after I factored out that 2, if I would have gotten an x minus 3, then I would have simplified it. Everybody good there? So I would accept either answer here. So again, factor the denominator first. This last fraction, this will factor into x plus 1, x minus 1. So that last fraction is set. That is your common denominator. The other two are missing. So let me go ahead and rewrite this and space it out a little. So x plus 1, I'm going to leave a little gap here. Okay, so for the first fraction, it is missing the x minus 1. So whatever you do the bottom, do to the top. The second fraction is missing the x plus 1. And the third fraction already has both. So now what I need to do is I'm just going to write down the common denominator one time. And now I'm going to go ahead and do the purple. It'll be 2 times x minus 1. Then the blue, 2 times x plus 1. And then the very last fraction, just the plus 1. So now I need to distribute the purple and distribute the blue. Once I distribute the purple, I get 2x minus 2. Once I distribute the blue, 2x plus 2, and then the plus 1. Still has the same denominator, x plus 1, x minus 1. And now I need to go back and look for my like terms. So I have a 2x plus a 2x, and that will give me 4x. Then I'm going to go back and add up all my constants. Negative 2 plus 2 is 0, plus 1 is 1. So plus 1 over x plus 1, x minus 1. You can leave it like that. Now I know I didn't multiply it back on the other one, but if you see it this way as well, you can FOIL that back and it'll turn back to what it was before you factored it. So just be aware of, let me get rid of the parentheses. Be aware that on an SAT or a PSAT, they may FOIL the denominator. So just be able to recognize that. You could have done the same thing on the one that I just boxed in red. If you wanted to have put it as 2x minus 5. I don't know what's going on here with my pencil. 2x minus 5 over x squared minus 9. If you wanted to have FOILed that, you could have put it in as x squared minus 9. So just be able to recognize both forms. And that is it for the adding and subtracting. Let me show you one more, a little bit more complicated one, because we got a lot of time here. Let me add one more example that's a little bit more complicated, just so you can see what it looks like here. Let's say this problem. 6 minus x over x times x plus 2 plus x plus 2 over x squared plus 8 over x squared times x plus 2. Lots of x's here. So my common denominator is going to be the largest exponent. So it's going to be the x squared, but then it's also going to be the x plus 2. So my common denominator is going to be x squared times x plus 2. And let me write it down 3 times. And now I'm going to go back up and I'm going to see what each fraction's denominator is missing. The first fraction is just missing an x. So because x times x will give me the x squared. So this one will be x times the 6 minus x. This one is missing the x plus 2. I need to FOIL that top, because you always have to combine your like terms. So I'm going to FOIL this in a minute. And then the last one has everything it needs. So it's just the plus 8. Now, we need to distribute the blue and FOIL the purple, and then combine like terms. So the blue becomes 6x minus x squared. The purple, after I FOIL that, is going to become x squared plus 2x plus 2x plus 4. When I add those, I'll get 4x in the middle. So the purple becomes x squared plus 4x plus 4, and then the last fraction has the plus 8. Now it has the common denominator in the bottom. And now I need to go back and look for my like terms. So notice here, the x squareds cancel. Maybe I shouldn't do it. Let me just do it in highlights so you can still see through it. Okay, then I've got to go back and I need to get my x's. So 6x plus 4x gives me 10x. Then I'm going to go back and get my constants, and I can add 4 plus 8, and that gives me 12. And then it's over the x squared times x plus 2. Now, if I try to factor the numerator, and I divide them both by 2, it doesn't give me anything that will cancel. So I would accept either answer. You could either leave it like that or factor out the 2. So again, always factor first, and then you multiply each individual fraction by what it's missing. But always factor the denominator, And then once you multiply the numerators by what they're missing, you either have to distribute or FOIL before you combine like terms.